Hello everyone. Welcome to our chemistry channel. Today we're going to explore how substances change from one state to another: solid, liquid, and gas. We'll use the kinetic particle theory to understand these changes and look at how temperature and pressure affect these transformations. Changes of state describe the process where a substance changes from one form, solid, liquid, or gas, to another. This happens when energy, typically in the form of heat, is added or removed from the substance. The kinetic particle theory helps us understand these changes by explaining how particles in a substance move and interact. When a solid is heated, its particles gain energy and begin to vibrate faster. This increased energy makes the particles push against each other, causing the solid to expand. This process is called thermal expansion. As heating continues, the energy becomes sufficient to weaken the attractive forces holding the particles in place. This causes the solid to melt and turn into a liquid. The temperature at which this transformation occurs is known as the melting point. For example, ice melts at 0 degrees Celsius. When a solid melts, the temperature stays constant until all the solid has turned into a liquid. This is because the heat energy is used to break the bonds between the particles rather than increase the temperature. Once the melting is complete, the temperature of the liquid starts to rise again. Substances with high melting points have stronger forces holding their particles together. For instance, magnesium oxide has a melting point of 827 degrees Celsius, indicating strong forces between particles. In contrast, ethanol melts at -117 degrees Celsius, reflecting weaker forces. When a liquid is heated, its particles gain energy and move faster. Some particles at the surface gain enough energy to overcome the forces holding them in the liquid and escape into the air. This is known as evaporation. As heating continues, the liquid reaches a temperature where bubbles of gas start forming within the liquid. This temperature is called the boiling point. For water, the boiling point is 100 degrees Celsius. At this point, the gas pressure above the liquid equals atmospheric pressure, allowing bubbles to form and rise. During boiling, the temperature stays constant until the entire liquid has turned into a gas. The added heat energy is used to overcome the forces between the liquid particles rather than increasing the temperature. Liquids with high boiling points have stronger forces between their particles. For example, water boils at 100 degrees Celsius, while methane boils at -164 degrees Celsius. When a gas cools down, its particles lose energy and move closer together. The forces of attraction between the particles become significant, causing them to condense into a liquid. This process releases energy. When a liquid cools further, its particles lose even more energy and move very slowly. The attractive forces between the particles become strong enough to form a solid. This process is called freezing, and it also releases energy. A heating curve shows how the temperature of a substance changes as it is heated. For example, if you heat ice from -15 degrees Celsius to 110 degrees Celsius, the temperature increases until it reaches 0 degrees Celsius. At this point, the ice starts to melt, and the temperature stays at 0 degrees Celsius until all the ice has melted. Then, the temperature rises until it reaches 100 degrees Celsius, where the water starts to boil. The temperature remains at 100 degrees Celsius until all the water has turned into steam. After that, the temperature of the steam rises. That wraps up our discussion on the changes of state from solids to liquids and gases. Understanding these processes is crucial for grasping basic chemistry concepts. If you found this video helpful, please like, subscribe, and hit the notification bell for more science content. Thanks for watching, and see you in the next lesson.